Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 18 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2163. Minimum difference in sums after removal of elements. Okay, so let's read the problem statement. You are given a zero indexed integer array nums consisting of 3 into n elements. Okay, so see this example number 1. Nums array given to us. Okay, what is the length of this? Length of this is nothing but 3, right? Okay, so here it is saying that you are given a zero indexed integer array nums consisting of 3 into n elements. Okay, so 3 into n, I can say 3 into 1, right? So 1 is nothing but n. Okay, 3 into n elements. Okay, now you are allowed to remove any subsequence of elements of size exactly n from nums. Okay, so n is 1, so we can remove any one element from this nums. Okay, so you are allowed to remove any subsequence of elements of size exactly n from nums. The remaining 2 into n elements will be divided into two equal parts. Okay, so if I remove any one element, I will left with just two elements, right? So I can say this is nothing but 2 into n. Okay, 2 into n is nothing but 1, right? So that's good, right? Length is 2 only, right? So you are allowed to remove any subsequence of elements of size exactly n from nums. The remaining 2 into n elements will be divided into two equal parts. Okay, two equal parts, right? So let's say I divide it like this. Okay, the first n elements belonging to the first part and their sum is sum of first. Okay, so n is 1. Okay, so one element here, one element here, right? The first n elements belonging to the first part and their sum is sum first. The next n elements belong to the second part and their sum is sum of second. Okay, the difference in sums of the two parts is noted as sum first. Okay, sum first minus sum second. All right, so for example, if sum first is 3, okay, and sum second is 2, then their difference I will say 3 minus 2, 1. Okay, similarly, if sum first value is 2 and sum second value is 3, then I am going to say difference is 2 minus 3 minus 1. Okay, right? So we have to return the minimum difference possible between the sums of the two parts after the removal of n elements. Okay, very easy problem statement, right? So now let's understand how we are going to solve this problem. Okay, so from this example, if you see, when I'm going to get the minimum difference, okay, this is what I need minimum difference. So when I'm going to get the min difference, so I will only get the minimum difference when here this side I have minimum value, right, and in this side I have max value, right? So see here, in the first side sum first I have min value only 2, okay, and in the sum second I have greater value 3. Okay, so then I'm getting the minimum difference. Okay, but if in this side I have max value and in this side I have min value, then in that case what will happen? So let's suppose just opposite this. Okay, 3 here and 2 here. Okay, then difference is 1. So out of these two, what is minimum? Minimum is this one, na? Right? So we are always going to get the minimum difference when the sum of second value is max and sum of first value is min. Okay, so we have to make sure that we will always get the minimum value in this side and some max value in this side. Okay, if possible, right? So that's what we are going to do, right? So now see this example number 1. So here 3 into 1, n is 1, so we can remove one element. Okay, so let's suppose if I remove this, so what I'm going to get 1 and 2. So difference between among 1 minus 2 is nothing but minus 1. That's it. Okay, minus 1, right? And same way, if instead of 3, okay, I remove 1, okay, then I left with a 3 and 2, right? So then difference is going to be 1. Okay, so let's suppose if I remove 2, then I'm left with a 3 1, then difference is 2. Okay, so among them minus 1 is the minimum, right? So minus 1 when we are going to get minus 1 when I'm going to remove 3. Okay, so here you can read the explanation. Num has 3 elements, so n is equal to 1. Thus we have to remove one element from nums and divide the array into two equal parts. Okay, if we remove nums of 0 is equal to 3, right, this is what we were doing here, the array will be 1 2. The difference in the sums of the two parts will be 1 minus 2 minus 1. If we remove nums 1 is equal to 1, the array will be 3 2, right. The difference in the sum of two parts will be 3 minus 2 1. Okay, if we remove nums 2, that is 2, the array will be 3 1. Okay, the difference in the sum of two parts will be 3 minus 1 2. Okay, and the minimum difference between the sum of two parts is mean minus 1 1 2. Okay, among them what is minimum? Minus 1. So we have to return this minus 1. That's it. Okay, very easy. All right, now let's understand how we are going to solve this problem with this example. Okay, all right, so these are the constant nums dot length is equal to 3 into n, which is given, right, and n value from 1 to 10 to the power 5 and nums of I from 1 to 10 to the power 5. Okay, now see this example. Nums we have, what is the length of this? 6. So I can say 3 into n. Okay, so this is in this form, right? 3 into n, so n will be 2 with them, right? Okay, n value, right, 3 into n, so n is 2. Okay, that's why we are going to get 6. Okay, so that simply means I have to remove two elements. Okay, two elements I can remove. Okay, so here n is equal to 2, right, so we must remove two elements and divide the remaining array into two parts containing two elements each, right. So let's write the array. Okay, so 7 9 5 8 1 and 3. Okay, so now I have to divide this array in two parts, right. Okay, and from here I can delete two elements. Okay, so let's suppose we have elements like this a b c d e f. Okay, so let's suppose I have deleted this b and here from here e. Let's say now in this side I will have two elements like this ac, and here I will have df. Okay, and you know when I'm going to get the minimum difference. Okay, when df I need it to be max. Okay, max, and ac, this left side sum, I need min. Okay, so when I'm doing min minus max, I will get some minimum value only, right. Okay, clear, right. So I want my ac to be max, ac to be min. Okay, I need to get the min sum here. Okay, of the elements. So here let's suppose my b is very big, 20. Okay, so I can simply 20 here, 1 and 3. Okay, I will remove this now, so that I will get just 4 here in this side, and let's say here 6. uh, in this side I need max. Okay, so 6 1 and 20. Okay, so let's say I remove this one. Okay, because I need max, so 26 I will get. Okay, let's say, so 4 minus 26 minus 22. Oh nice, minus 22 will be the minimum. Okay, so this is what you need to do, right. So how I'm going to solve this? Okay, so here we have just deleted b and e, but how we find out that we have to delete b and e or any other? Okay, so we have to see that. Okay, so now let's understand that. Okay, so let me just remove this. All right, so here this is my array, right, 7 9 5 8 1 3. Okay, so here let's say this is one array. Okay, of same length. Okay, 1 2 3 4 5. Okay, so from here 3 into n, right, this is the structure, so n is nothing but 2. Okay, so two elements we need to remove, right. Okay, from here, so if I remove two elements I left with 4. Okay, I can say 2 into n. Okay, 2 into n is nothing but 2. 2 into 2 is equal to 4, right. So that simply means two elements here in this side, two elements here in this side. Okay, so here in this two I need what? I need min. Okay, so I need min. Okay, so right now I have just this 7. Okay, I have just this 7, so I don't have 2 right now. Okay, so let's say only I'm here only, right, in this side. Okay, so only I have 7 right now until here. So in the left side I don't have any other value other than this 7. Okay, so I can say that I need min, right. I have only one element, so I can say infinity. Okay, max value. What is the max value? Infinity. Okay, I am storing here minimum value that I have seen in the left side of the two numbers, right. Now let's suppose next time my I reaches here. Okay, now in this side you have two numbers, 7 and 9. Okay, so 7 and 9, if you do the summation of these two, 9 and 7, you are going to get 16, right. 9 10 and 16, yeah, right. Okay, this is done. All right, so now next time I need min. Okay, that is why I'm taking max value here. Okay, now my I reaches here. Let's suppose. Okay, in this part I need two numbers. Okay, and I want this to be minimum. Okay, so I'm checking about this part. Okay, left side part. So 7, 9, 5 among them. What are the two smallest one? 7 and 5, right? So what is 7 plus 5? 8, 9, 10, 11, 12. Okay, so 12. So this 12 is nothing but the combination of 7 plus 5. Okay, this 16 is nothing but the combination of 7 plus 9. Okay, this infinity, because we have just 7, we don't have any other number, but we need to maintain here minimum values. Okay, so here I'm just writing the max infinity. Okay, because in the end I need minimum value only, right? So I'm definitely going to ignore this individual part. Okay, right. Now next time here my I is going to move here. So now again in this part, what is the minimum value you are going to see? 7, 5, all right, 12 only. So you can say 7 plus 5. All right, now next time your eye is going to reach here. Okay, so now in this, when you are here, okay, so among in this side, what are the two minimum values? 5 and 1. Okay, so 5 and 1 is nothing but 6. Okay, 6. So here you are using 5 plus 1. All right, now next time you are reaching here. Okay, your eye it is here. Okay, at this position, right? So in this side 1 and 3, 4. Okay, that's it. 1 plus 3. All right, okay, this is done, right? So this is I'm talking about the left side. Okay, so in the left side you are getting this array, infinity, 16, 12. Okay, then 12, 6, 4. So you can say that this is nothing but a left total. Okay, left total, left total. Let's say this array name is left total. Okay, this is done. Now same way here, right total, right total. Okay, so just create similar array like this only, right? Same size, 1, 2, 3, 4, 5, 6. Okay, so now in the right side, what you need? In this side you need max values, right? In this side you need max values. Okay, so max values. All right, so now just iterate opposite. Okay, from the right side you need to check, right? So my I here initially, right? So only 3 I have now, but here in this I need 2, and 2 should be max. Okay, so here I'm just going to store the minimum value. Okay, minus infinity, right? Because here in this side I want to keep track of the max values. So here just 1, so just take minus infinity. Okay, minus infinity opposite. Okay, we are taking opposite because here in this side I need the max. Okay, so here we need min, so here I'm keeping the max. Okay, so that since I am dealing with min only, so I will use this. Okay, I will definitely ignore, going to ignore this. Okay, so this, now here in this side 1 and 3, my I reaches here. 1 and 3, only two values are there. Max is 4. Okay, that is nothing but 1 plus 3. All right, now here my I reaches here. Okay, now when my I is going to reach here, so in this side 8 and 3. Okay, 8 plus 3 is 11. 9, 10, 11. Yes, so 8 plus 3. Okay, since in this side we need the max values, right? So here I'm just taking the max values. Okay, next time my I is going to reach here. Okay, so 5 and 8, so that is 9, 10, 11, 12, 13. Okay, right? So here this is nothing but 8 plus 5. Okay, then next time my I is going to reach here. Okay, so in this side 9 and 8 are the max. 9 and 8 is nothing but 17, right? So this is nothing but 9 plus 8. Okay, then next time my I is going to reach here. Okay, reach here. So in this 9 and 8. Okay, 9 and 8 is 17. All right, 9 plus 8, 17. All right, so I have filled these two arrays. Okay, one is left totals, right? And here this is nothing but the right totals. Okay, now from here I can simply get the answer now, right? How I'm going to get the answer? So I am making a split based on I value, right? So if I am splitting here, so let's suppose until this index. Okay, until this index I have the total left total. Okay, and in this part I have the right total. Okay, so in this part I have left total, and in this part I have the right total. So this is what I need to do, right? Right total. And here in both sides left total, I'm just taking two values every time. Okay, two values. Here also I'm taking two values. Okay, the values that I'm filling here, these are of 2, right? Only two twos I'm taking, right? Here this is what the requirement is, right? So now here definitely I'm going to ignore this infinity. Okay, so let's say if I make a split here, okay, if I made a split here, so in this side, okay, the total values in the left is 16 and the total values in the right is 13. Okay, 16 minus 13, so value is 3. Okay, this is one split. Now next time, this is the split. Okay, this is the split, right? So here in this side 12, and here in this side if you see 11. Okay, so 12 minus 11, so that is nothing but 1. Okay, so this 12 is coming from 7 and 5. Okay, and this 11 is coming from 8 and 3. Okay, 8 and 3. All right, so that simply means 7 and 5 I'm taking, I'm deleting this 9, and 8 and 3 I'm taking. Okay, I'm deleting this one. Okay, this is for this split. Now if you see there is one more split I can do here, right? Okay, so here in this side 12. Okay, and now in this side if you see 4. Okay, 12 minus 4, this is nothing but 8. So among them minimum is 1, so this is your output. Okay, so your output 1, right? So why I'm starting from here and I'm stopping here? Why? Because I'm starting from here because in this side I need two values. Okay, I need at least two values. So from here only I will get two values. Okay, so see, this is of size 6. Okay, size 6. So let's say A, B, C, D, E, F, 6 size. Okay, so first split I'm doing here now. Why? Because I need these elements A, B, and C, D one side. Okay, next time I'm doing this split because I need this B, C, D, E. Okay, right? BC one split and DE. Okay, next time I am splitting here because in this I will get CD and one side I will get EF. After that I will not split now because only one element will be there then, right? Okay, so I need two twos, right? So that is a reason. Okay, so we have to run our loop for only these indexes. Okay, these indexes, right? Okay, so here 3, 1 and 8. So 3, 1 and 8. Okay, 3, 1 and 8, minimum is 1. Okay, so now here if you read the explanation now for this one. Okay, so if we remove nums2 is equal to 5 and this and nums3 of 8, then we are left with 7 plus 9, 1 minus 3, 12. Okay, not good. Okay, to obtain the minimum difference we should remove nums1 of 9. Okay, this, and nums4 is equal to 1, so we are going to get 7, 5 and 8, 3. Okay, so 7, 5, 8, 3, the difference is 1. Okay, so it can be shown that it is not possible to obtain a difference smaller than 1. Okay, so this is the same thing we are doing here, right? Okay, here 3, 1 and 8, right? Okay, so here minimum we need, right? Okay, so this is clear, right? So how here I am keep tracking of the two values only, right? Every time I'm keep tracking of the two values. So how I'm going to find out these two smaller values, right? So you can use periodic queue for this, right? So for this one you can use MaxHeap. For this one you need this is the right side, right? Right side. So this side you need min. Okay, MinHeap, you can use MinHeap, right? Since you want to take the max values, right? Okay, so here let me explain. This is your left total. Okay, so here what you need min values. Okay, so definitely the bigger values, okay, you are going to use MaxHeap because here uh, until here, let's suppose, if you use MaxHeap, then definitely 9 is going to come top, then 7, then 5. Okay, since you are using MaxHeap for left total, you can easily remove this. Okay, top value. Okay, top value 9, because we are not going to use this when we are going to reach here, right? Right, because we need smaller values. Okay, so smaller values will definitely come to the bottom. Okay, if I'm going to use MaxHeap. Okay, so I can easily delete this. Okay, so I will just check one condition. Okay, if the my heap size, okay, if it becomes equal to n, then just do the sum. Okay, and just put it here. But if it becomes greater than the sum, right, if it becomes greater than the length, okay, n value only two needs now. So if it becomes 3, then just remove the top one. Okay, as soon as it becomes 3, just remove the top one. Okay, so that we only maintain 2. Okay, and whatever the sum we are going to get, we are just going to add it. Okay, and we are not going to add any sum here if the size is not equal to 2. Okay, n. Okay, so only if it is equal to n, we are going to add this 16, 12, 12, 6, 4, 4. Okay, if it becomes greater than n, then since we are using max heap, the max value will come to top. I will directly delete that. Okay, so here priority queue will come nd. Okay, so we are going to use both max heap for this left total and min heap for the right total. Okay, and then we are going to calculate the differences. Okay, so here uh, this this is having size 3 into n. Okay, n is 2, right, n is equal to 2. So you are going to remove two elements, right? So two elements will come this side and two elements will come this side. Okay, so you are starting from here. Okay, so I can say that you are going to start from your I from n minus 1. Okay, so n minus 1. Why? So here if I just give the indexing of these six numbers, okay, 0 1 2 3 4 5. Okay, so n is 2, so 2 minus 1 is nothing but 1. Okay, so that simply means you are doing one split here. Okay, on this b, so this side values and then I plus 1. Okay, these values. Okay, right. So, and you are going to do this until here. Okay, so I can say that you are going to run from one loop from I is equal to n minus 1 to I less than 2 into n, right? Why 2 into n? Since here 2 into n, if I do, I will get 2 into 2, that is nothing but 4. I is less than 4, right? So my I is running for 1. Okay, then I'm doing split here, I is equal to 2, I'm doing split here, I is equal to 3, I'm doing split here. After that I need n elements now, so that's why I'm stopping here. Okay, so only until these three indexes. Okay, I is equal to n minus 1 2, I is equal to less than 2 minus 2 into n. I will run one loop, and using that loop I will just find out these values, and among these values I will just take the minimum one and I will display that as output. Okay, whatever the minimum. Okay, so now let's write the code. Very simple, same story, whatever I explained I am going to do the same thing. Okay, so let's move to the coding part. All right, so here first thing that you need to do here, just calculate the n value. Okay, so n is nothing but int n is equal to nums dot length, right, and here it's divided by 3. Okay, so why I'm writing it like this? So here it is saying now you are given 0 index integer array nums consisting of 3 into n elements, 3 into n elements. Okay, so this is nothing but the nums dot length. Okay, right, so I can say that your nums dot length is equal to 3 into n. Okay, so if I want to calculate n, so I can say now nums dot length, nums dot length, and this 3 is going to come to the bottom. Okay, right, so that's why n is calculating like this. Okay, that's easy, right? Now here length. Okay, length, total length of this nums array, I can say a simple nums dot length. Okay, now this is done. Now here after that let me add the comment left min heap. Okay, so left min heap, I can say max heap. Okay, max heap to track n smallest. Okay, and only n need, right, n smallest values. Okay, done. All right. Okay, so this is done. So this is how I'm going to do that. Okay, so here you have to do here just write it like this now. Left, in the left side what we need, left total. Okay, for, or you can say left sum, right? So left sum, for left sum I'm going to use max heap to track the n smallest values. Okay, so yeah, use it like this. Okay, otherwise you guys will get confused. Priority queue. Okay, so we can use priority queue, right? In priority queue what we are going to pass, we are going to pass integer, and let's name it as left heap. Okay, so left max heap. Okay, max heap we have to use now, so left max heap. Okay, this is done. And by default in Java a priority queue is a min heap. Okay, so you have to reverse the order. All right, so new priority queue. All right, and here what you need to do, new priority queue. Okay, this is normal. Okay, normal way, right? That's it. But since this is min heap by default, so we have to reverse the order. So what you need to do inside this, you have to just pass collections dot reverse order. That is it. Okay, reverse order. Okay, that's it. Now no need to change anything else. That's it. Okay, so we have created priority queue. Now left sum. Okay, so long, here you can say left sum. Okay, and here you can say new long, and what is the length of your nums array? You have calculated here in this variable length. Okay, total length of your nums array, right? And here int left total, initially just set it to 0, right? Now I'm going to iterate over all the elements one by one. Okay, I is equal to 0, I is less than length, and here I plus plus. Okay, and inside this, in the left total, okay, I'm just going to add the nums of I value. All right, nums of I value, right? So once I add this, so I'm going to add this into my heap also. Okay, left max heap dot offer, in this I'm just going to pass nums of I value. Okay, so I have added this. So right now only one element is there in my heap. Okay, so here if my size of this left max heap, okay, left max heap, okay, if the size of this becomes greater than n, then in that case, as soon as it becomes greater than n, okay, so just do one thing, whatever the left total you have, right, on from this, just subtract the left max heap dot poll. Okay, topmost element. Okay, so just copy this dot poll. All right, done. So we have to remove the largest to keep n smallest. Okay, so let me add the comment as well. Remove the largest to keep n smallest. Done. Okay, once this is done, so this is for as soon as its size becomes greater than n. Okay, but here if left max heap dot size, okay, if it becomes equal to n, okay, so as soon as it becomes n, that simply means we have two elements only, right? So if we have two elements only, so you have to operate your left sum of I, okay, your array with the left total you have, current left total that you have. Okay, left total, right? Done. And in the else part, if size is still less than n, okay, so in that case, since we need, in the left side we need min values, right? Okay, min values, right? In the left side we need min values. Okay, okay, so here I can say left sum of I will just pass the max value. Okay, so here long dot max underscore value, that's it. Okay, so this is done. All right, okay, now same thing. Okay, this ends, this is your priority. Okay, this ends here. All right, so yeah, so you can just take this. Now same thing we have to do for the right part as well. Okay, so in the right, okay, so here I'm going to say right sum. Okay, so for right sum, what we need min heap. Okay, min heap to keep track of n largest values. Okay, in the left side we need largest. Okay, largest values, right? So priority queue, so by default it is min heap only, so we don't need to write this. Okay, and here left max heap, so instead of this, just we have to change it to right min heap. Okay, so here right min heap. Okay, RIGHT. Okay, spelling mistake. Right min heap. Okay, so here you have to use right min heap. Okay, let me just change it here as well. Right min heap, here also right min heap. Okay, right min heap dot offer, and here also right min heap. Okay, and here also right min heap. All right, so let's, okay, so here left sum. Okay, so just change it to right sum. All right, so right sum is equal to new long length. Okay, same here also you have to change it to right total. Okay, and here this time you have to reverse the loop. Okay, so here length len minus 1, and here I should be greater than 0, greater than equal to 0, right? Okay, greater than equal to 0. Okay, and here it should be I minus minus, right? I hope that I'm not doing any mistake here, right? So here right total, so right total, so just change it to this right total is equal to right total plus this nums of I, and then the right min heap you have to add this. Okay, so if right min heap dot size it becomes greater than n, then your right total, okay, so here just change to right total minus is equal to right min heap dot call. So we have to remove the smallest, okay, smallest, okay, since we are using min heap. Okay, so smallest to keep n largest. Okay, so here largest, right? This is done. And here once this is done, if right min heap dot size is equal to n, then right sum of I. Okay, then this right sum of I is equal to right total. Okay, so this is nothing but right total, right total. Done, right? Okay, so here as your right sum of I is equal to right sum of I is equal to long dot, since here we are keeping track of the large value. Okay, so here I will take min. Okay, min value, that's it. Okay, so these two parts are done. Now in the end we have to just calculate the difference, that's it. Okay, so we are able to do this, we are able to do this. Now just calculate this. For this I already told you we have to run the loop from n minus 1 to less than 2 into n. Okay, so this is done. All right, so here now compute the minimum difference. Okay, so long result is equal to long, okay, dot max underscore value, right? And then you have to run one loop for int I is equal to n minus 1, and here I is less than 2 into n, and here I plus plus. Okay, done. And here just make sure left sum of I value, okay, it should not be equal to the long dot max underscore value. Copy this, paste it here. Okay, done. And your right sum of I value, okay, it should not be equal to your long dot min underscore value, right? Okay, so if this is not the case, then here you have to just update your result as so we need min, right? So math dot min, okay, whatever the result, okay, old value and now new value, how I'm going to calculate. So left sum of I, okay, minus right sum of I plus 1 here, right? I plus 1. So this is what we were doing, right? Okay, so here this side, okay, split is here now, so this side in the for the left, and here this side for the right. Okay, for the elements, two elements from here, two elements from here, right? So this is done. Okay, right, this is done. Now here in the end you have to simply return result. Okay, so now let's run the code and see if there are any code issues. We'll try to fix that. Wow, nice. So all the test cases has been accepted, right? Okay, now let's submit it. Okay, so there is some issue, so let's see why we are getting this. Okay, so 108 test cases got passed, only 2 are failing. Okay, so I think somewhere we are not using long or something, so we have to see that. Okay, so here if you see why I'm using int, okay, values can be very large enough, so that's the reason long. And here also let's use long, I think that's the only reason. Okay, so that is why the values are changing here, right? So now let's submit it again. I hope I'm not doing the same thing anywhere else. So see, nice. So our solution is also accepted, right? Okay, so I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you, bye bye.